Makes me wanna take a back road. Makes me wanna take the long way home. Put a little gravel in my travel. Unwind, unravel all night long. Makes me wanna grab my honey. What is going on, calculus? Hope everybody's doing amazing. A little intro music for you there. All right. Today we're going to be talking about continuous functions. Oh yes, love continuous functions. Everything that has to deal with them. The one reason why I'm really a fan of continuous functions is because of how important they are to calculus. Continuous functions are going to play a vital role throughout pretty much the remainder of the year. So we have to be able to tell whether something is or is not continuous. That's what we're going to be doing today. Now, being continuous, there are three very specific things that need to happen. All right. Function f of x is continuous at c if all of the following conditions exist. First off, the function has to exist at that point. So if you plug in that point, it's got to exist, meaning no undefines or anything like that. Next, the limit of the function as x approaches c has to exist. So none of this going to two different values. All right. And lastly, these two things have to be equal. The limit as x approaches c of f of x has got to equal f of c. The limit has to equal the actual value, and we call that continuous. Okay, so what happens if it's not continuous? It's really easy to tell if something is not continuous when you look at it. So that's what we're gonna do here. These are reasons for being discontinuous, not continuous, in other words. So a couple of things that I'm going to show you here. First and foremost, this one, f of c is not defined. That goes back to number 1 up here. F of c has to exist. See this value for c? The function doesn't exist at this value. It's not there. F of c does not exist. Therefore, this function is not continuous. It's got a hole in it. Think about just the English term of what continuous means. It means no breaks, no gaps, right? No asymptotes, none of that stuff. So continuous means it's a smooth, continuous curve. Going down here to the second one, see here, f of c is defined. If we go to c and we were to plug that in for f, it'd be this point right up here. It'd actually be this y value. However, the limit as x goes to c does not exist because it's approaching two different values. From the left, it's going up here. From the right, it's going down here. The limit does not exist. So since that's the case, this thing is not continuous. The function does exist, the limit does not exist. All right, so let's say that the function and the limit do exist. F of c is defined and a limit exists. F of c, if you go to c and plug it in for f, you're going to get this point. This is like a piecewise function. You're going to get this point, right? This y value. The limit, however, is what it's approaching. So the limit is down here. It's this y value. So the limit from the left and the limit from the right are the same. That means the limit does exist here. But if you notice, the limit does not equal f of c. The limit is not the same value as f of c. So these are all discontinuous. F of c doesn't exist, the limit doesn't exist, or they do exist but they're not equal. All right? So let's go over and let's use that information and let's actually come up with some stuff here. You may see a little shadowing right here in this problem. I actually started this a little bit earlier and I had to stop because they called into my room and made me go run an errand. So I went ahead and erased it. We're just going to start over, okay? So starting on example 1 here, there's a couple of things I want to kind of bring to the forefront of your mind. The very first thing that I do on these is always to try and simplify. You're trying to think about, does the function exist? You're trying to tell me, is it continuous? Well, if you want to see if it's continuous, first you need to see, does it exist? Just like number 1 here says. So what I'm looking for, is there a number
that I can put in for this function to make it undefined. In other words, let's factor the top and bottom here. On the bottom you have x minus 3, or on the top rather. On the bottom you have x minus 3, x plus 3. If you notice, these two cancel out, and we learned a few days ago that that means there is a hole at x equals 3, right? There's a hole there. All right, so let's keep going here. On the bottom, if you were to plug in, let's say f of negative 3 to make this bottom 0. Let's say we plug in f of negative 3. We know that's going to give us a 0 in the bottom, right? So I'm going to say that the function doesn't exist at negative 3 because it's an asymptote. It makes the bottom 0. Or you could also say that as the limit as x goes to 3, negative 3, excuse me, as it goes to negative 3 of the function f of x, that also does not exist, right? It's an asymptote. The limit doesn't exist there, okay? It's approaching two different values. If you look at it, this is one where one side goes down and the other side goes up. One goes to negative infinity, one goes to positive infinity. Now, because there is a hole at positive 3, I know that f of 3 also does not exist. Okay. Since f of 3 and f of negative 3, there are two spots here where your function has an issue. This is discontinuous. And it's discontinuous at x is equal to positive and negative 3. There are two spots where this thing is discontinuous, a positive 3 and a negative 3. At positive 3 you have a hole, at negative 3 you have an asymptote. Alright? Let's go over here to example 2. Now on example 2, the degree on the top is the same as the degree on the bottom, so you know you're going to have a vertical asymptote here. Let me just draw you a quick sketch of what this is going to look like. If you were to divide this thing out, sorry, let me straighten this up so you're not looking at it crooked. You'd have down here negative 1, up here positive 1, right? And then since these are the same on top and bottom, you know the function's it's gonna be 1. But there's a problem here when you get to positive 3. I shouldn't put that quite like that. Let me write that a little bit smaller. At positive 3, there is an issue on both sides of this. Since you've got the same thing in the top and the bottom, you know it's going to simplify to either 1 or negative 1. So over here to the left, it's going to give you negative 1. To the right, it's going to give you positive 1. So let's really think about that. First off, what's your problem, child? It's 3. So you're going to look at f of 3, and you're going to say it does not exist. There is no f of 3 here. You cannot put a 3 in here because you will be dividing by 0. Or you could say that the limit as x approaches 3 of f of x, since we're going to two different values, positive 1 from the right, negative 1 from the left, you can say that the limit does not exist. Those are two reasons why this thing is not continuous, just like we did over here. Two reasons why this thing is not continuous. So now that I have shown that and I have proved that, I'm going to say it's discontinuous at, there's one value, x is equal to 3. So you're going to look at what's your problem, child? Are you ever going to have a hole? Are you ever going to have a gap? That's what I'm looking for. Okay? And if you are, show me that it doesn't exist. That tells me that it's discontinuous. Now the reason I put or in here is because either one of these are valid answers. You could have just said f of 3 doesn't exist, not continuous, and that would have been a perfect answer. You could write this one, the limit as x approaches 3 of f of x does not exist. That's reason 1 and reason 2 on the front page. Both of those are perfectly fine for proving that it's discontinuous. And what you're going to see a lot of coming up in the next few months is on the AP exam, especially what I'm going to be making you do in here is proving why something doesn't exist. You must show evidence Simply saying that it's discontinuous, even though that is a correct answer, is not giving you credit. You will not get credit for just get discontinuous. You must prove your answer, and that's evident by this last word right here. Justify. Justify. You must justify your work. This is a must-have. If you do not show work, you will not get credit. It's just how they work. It's how they operate. All right. Down here at the bottom, let's get into some of these here. F of x as x is to the left of 2, less than or greater than. This is the left of 2, and x is to the right of 2. We have a piecewise function here, 2 pieces to a function. So obviously something is happening at 2, right? At 2, something is going to happen. You're popping from one equation to another. That's where your issue is going to be if there is one. So let's see what happens. Say in the top here we get negative 2 times 2. Plug in your 2 in here. You get negative 4, right? Down here, if you plug it into here, well, okay, yeah, let's go ahead and do this here. Down here, if you plug 2 into this bottom equation, let's say we're looking for the limit. It's got to be the same on the left and on the right. So I'm going to plug 2 in down here. 2 squared minus 4 times 2 plus 1. 2 squared is 4 minus 8 plus 1. It's going to give me a negative 3. So if I was to take the limit as x gets close to 2, as x approaches 2, go ahead and write that down. I'm going to skip a space because I'm going to put something above that. The limit as x approaches 2 of f of x is going to 2 separate numbers, negative 4 and negative 3. Since that is the case, this limit does not exist. Now if you were to actually plug 2 in, say we wanted to actually find out what is f of 2, you go to the equation that includes 2. Here x is 2 is included in the x values. So f of 2 is negative 4. See how these things are not the same? So for 2 different reasons this thing is discontinuous. The first reason is that the limit doesn't exist. The second reason is that, like number 3 on the front page, there's a spider on my camera. That's a distraction. Number 3 on the first page says that these two have to match. So I'm going to write therefore. 3 dots mean therefore it is discontinuous. And it's discontinuous where? At x equals 2. Get this spider up. Die, son. Okay, sorry about that. Spider's got to go. So it's discontinuous at x equals 2. Anytime you have a piecewise function, this value is going to be where the issue is at. If you think about it, I mean a piecewise function, just if you think about it, at x equals 2, right? Where x is less than 2, it's 2 minus x, which is a positive 2 and a negative value for x, so it's going to be something like this with an open circle here. And then where x is greater than or equal to 2, it's x minus 2, so shifted right 2, so it's going to be something like this, square root sign, open circle here. Think about it. If there's ever going to be a problem, it's this guy, right? So let's go through and let's actually work this thing out. Starting off, what is f of 2? What is f of 2? Technically, I should have done this one first over here, but I got ahead of myself. What is f of 2? So I'm going to go to where 2 is included, x is greater than or equal to 2, plug it in. So that's going to be, let me do this up here, the square root of 0 minus 2, always in parentheses, right? Good grief, it's not 0. Square root of 2 minus 2. What am I thinking? Which is the square root of 0, which is 0, right? So f of 2 is 0. Let's look at what the limit is. The bottom one goes to 0. Say we